Hello all. So in this section of the video, we're going to take a look at the evaluation step. So once you've trained the model, various different things you can do to try to see or calculate statistics about its performance in using Scikit-Learn. So I'm going to transition into that. We'll join the video perhaps right in the middle because I just recorded it all as one big long video. But we'll focus for this just on those evaluation steps, and good luck. Okay, we're going to go back. We've trained a model. We want to be able to evaluate it. And I show you several different methods for evaluating it. I'm going to show you the kind of dumb one first. So what I wanted to do was I wanted to show you that there is, the classifier has a predict method. You can pass it an array of data and it will provide an array of predictions for it. So I can, if I want, by hand calculate the accuracy on the validation data. So I can take the validation X and Y, I can run the predict on the validation X, it'll give me predictions, and then I can check whether or not those predictions are equal to the correct value or not. And in this case, I'm keeping count of them, so I can then calculate the accuracy at the very end. You don't need to do this. As it turns out, there's a function to do this, but you can see I'm calling this function. I'm passing it the k-nearest neighbor classifier that was just trained and the validation data that we provided to it. I guess we actually don't provide the validation data here. When you call fit, you just pass the training data. All right, so now when I run this, I'm going to have a lot more output. This is my by hand check function. I'm testing each and every one. You can see it is mostly correct. Here it was supposed to be category 1 and it said category 2. I think that's the order. Here it also had an incorrect result, but mostly it was pretty good. And the by hand accuracy calculation was 9.3, more or less. Now, accuracy is the most common metric. It's like the baseline. It's easy for us humans to understand. We like to look at it. Because of that, you don't actually have to calculate it yourself. So the by hand check function isn't necessary. I gave it to you in part, as I said, just because I wanted to show you that you could how to use the predict method. There is, in fact, a method called score. You pass it some data, you pass the trained model some data, and it will report the accuracy back to you. And you can pass it the validation data as well. So I'm going to comment out my call to by hand check because we don't need it. I guess I don't have to comment out the function, just comment out the call. I say that to my intro students all the time. Let's run this. Notice the k-nearest neighbor doesn't take a lot of time to run. That's one of the lovely things about it. All right, so on the training data, the accuracy level was 97.5%. And on the validation data, this is showing us that we did the other function right. The validation data its accuracy is 93.3%. So the score for a model in Scikit-Learn is its accuracy. Accuracy is a good starting point. Often we want more interesting data, more different kinds of metrics. I went over different metrics in the earlier video. I just want to show you a couple here before, as the second to the last of our topics. All right, I actually just added this in because I realized I did want to show you the classification report and I just had not actually included that in the code. So there is a function for getting a classification report. This reports precision, recall, another metric called F1. It also does some averaging. It just shows you a lot of different metrics for the particular model that you have. You call it and you pass it the actual targets and then you pass it what the model predicts for the same data. And there are some optional arguments. You can put in the category names if you have those. I didn't happen to grab those out of our iris data set, so I could try to figure that out. sorry, target names equals irises target. Oh, treat it like a dictionary. See if that works. All right, so I wrote a little function. We pass in the classifier and an X data set and the Y targets that go with it. We call the predict method, pass it the X, which gives us the Y predict, and then we print out the classification report. I've done this, I've called it here with the validation data for the iris data set, and I can call it also if I want with the training data. And I'm going to add a little print statement in between and one before, just so we have things spaced out a little bit. All right, let's try running this. We'll see what it does. All right. All right, so here you can see the output of the classification report. It makes a nice tidy little table where it has calculated for each of the different kinds of irises, the precision the model has on it. You can see that it's Virginica, that is where it's getting the errors. It also does the recall. It calculates the F1 score, which is the harmonic mean of the precision and recall. Support, I think, has to do with how many examples there are for each category, but don't quote me on that. It's giving you the accuracy score here, and then it does these which are averages over the three categories up above. So this first table is, you look at the 97.97, this first table is showing you the results for the training data, and then if you look at the results for the validation data, you can see that they are good, but not quite as good as the training data, which is what we expect. And we get 93% accuracy. The other metric that I want to look at is a confusion matrix. So there are two parts to this. You can create a confusion matrix, which is just an array, and you can print it. And then you can also do it with have a matplotlib display a very nice form of it. So this code will do both. I'm not going to show you the nice form. It's going to pop up in another window, and that's just going to be a lot of work. But what you can do is, if you want that display, you say confusion matrix display from estimator, you pass it the classifier, you pass it the X data and the Y data, and a couple of other things. Do you want it to normalize the data? What color scheme should it use? That's what this one is telling it. And then it will actually pop up a window that shows it in a very nice form. I'm also printing, once you've run this, you notice it's setting up this DISP object. The DISP object has the data for the confusion matrix in it, so you can actually just print that data and look at it. So we talked about a confusion matrix in the earlier video. I'm not going to go through exactly what it is, but you'll note that it was in fact printed out here. So I think these are on the training data. You can see unnormalized or normalized. So normalized means it'll scale them to be percentages. So they go up to 1. And unnormalized, it gives you the raw counts. So this tells you that 34 of the second category were correctly categorized and 3 were not, and so forth. And then I have the same thing for the validation data as well. The last topic, oof, this is going to be a long video. The last topic, I may break it up a bit, is crossfold validation. It's an important thing to understand how to do when you're not doing deep learning. It's a key piece that I think you should probably always try. And so what we're going to do here, I have to uncomment this code so we can see it. What we're going to do is make a brand new k-nearest neighbor classifier that has not been trained. That's kind of important. We make the classifier, but we don't train it. Crossfold validator will train the model for us. So I'm passing it my untrained model. I'm passing it the training data, the X and the Y, and I'm telling it how many folds. should it do? And remember, crossfold validation, it takes that data, it will segment up the training data into this number of sections equal sized, and then it will repeatedly train the model on 4 of the 5 until it has tried all subsets of 4 and used each and every one of those 5 folds as the validation for the whole thing. Now notice I'm doing this on the training data. I've already excluded the validation data, so I'm only looking at 80% of the original data set. You could pass the whole data in here, but you could also think that, oh, well, the one that I was calling validation, I could be using it as a test data. This will automatically pull out some validation data from what I'm passing in here. And then I'm just going to have it print out a couple of the statistics that it calculates. So this is the last run. I got to close all of my Matplotlib windows. And let's pull this up and take a look. So the cross-validation scores, 1, 2, 3, 4, 5, it's telling us the accuracy across all 5 folds. You can see that they range from 0.96 to 1, and the mean and standard deviation look pretty good. So that means that we're getting pretty consistent results. This accuracy that we got on our other attempt is right in line, and so there wasn't anything unusual about it, and this is the kind of results we should expect to get. All right, that was a lot. There's just a lot you can do with these models, and this activity is too long. If you just walked through what I did and examined it, it would take you most of our class period. So you'll have a chance to continue playing around with this and going back and trying other examples. One of the tasks on the homework is to actually go through and finish at least some of these other models, and to experiment with trying multiple models on the same piece of data and seeing which models work best. I'm going to stop there. I will see you all very soon.